Now, today is kind of your first day that we're going to really start challenging you on how you think, okay? So, what do I mean by that? Well, up to now, you've been basically multiplying stuff out. Even like today, we were just multiplying on that quiz. Multiplying, adding, subtracting, like terms, all that stuff. Today, so you've been kind of building the car. Today, you've got to take the car all apart, okay? Which is an entirely different skill. And maybe some people think, well, it's easier to take a car apart than to put it together, okay? I'd agree on that one, but when it comes to dealing with polynomials, it is actually easier to put them together than it is to take them apart. Yes, thank you. Now, the first thing we're going to start off with is, what's the lowest common multiple of 2, 6, and 15? Now, the big thing that always comes up is students are like, GCF, LCM, I always get those two all mixed up. Like, I don't know which one. Like, am I doing the stuff that goes in? Am I doing stuff that they go into? Like, what is it? And the way I always do it is I think of the LCM as always the L. Okay? And when you multiply the L, you're going to get a bigger answer than if you just multiplied the side. So I look at the bigger one as the L. Okay? So if I was to set this one up, I would set my 2, my 6, and my 15 just like that. And then I draw one of these. Now, the rule is, remember, at least 2 of them. But if you can do all 3, you need to, or else you'll get the wrong answer. Yeah? At least 2. Yeah. Mm-hmm. Yeah. Okay, so what would I start with? I can't even do something for all 3. So I'm already compromising. You start with 3 or 2. Doesn't matter. Okay, so start with 3. Now, if you can't do it, you just drop it down. But I want you to draw that arrow in there, because then when you come to your notes later, and there's no arrow, then you can be like, what did I do? How did I get the 2? 3 is divided by 2. We actually drop that because it doesn't divide. And then I'm going to get a 2, and I'm going to get a 5. Okay? Now, what would we pick? 2. Okay, so that would be 1, 1, and we're going to draw the arrow to bring down the 5. Now, it doesn't matter, you can stop here, or when 1 is the only thing you can do. But at this point here, I can't go anymore, so I can draw my... So, I am doing my L, which is 3 times 2 is 6. 6 times 5 is 30. Okay? So it's just multiplying all these together. Okay, now doing it with algebra tiles. Greatest common factor. Now, greatest common factor and algebra tiles, they do kind of make sense. And some students in the other class said, so if it's like GCF, does it make something closer to a square? And it was a good observation. Okay? So if you look at, if you had 8 X tiles and 4 unit tiles, so that's the same thing as what if it was an equation? How do you, 8x plus 4. Now, if you had 8 of those long skinny tiles and 4 of those little small ones, those units, it says, well, make rectangles. Well, the most obvious rectangle to me is 8x plus 4 times 1. Right? Because then it's like 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4. Yeah. See, that one is the farthest from a square. Okay? Now, what is another way that we could arrange our tiles to make a rectangle? Mm-hmm.
Have like 4x, 4x.
Okay, well, I only can deal with these guys here. I have 8 of these, and then these little guys. So I can't even make x squareds.
No, I mean like like 4 and 1 row and 4.
Yeah, so you want to go 4 and 4. So what you're saying is you want to go 2 this way, and so if I went by 2s, right? Okay, then there's okay, what's that side dimension? 4x plus 2. And you see that 2 times 4x plus 2 is the same thing as 8x plus 4, right? So it's still correct. What's another rectangle? 2x plus 1, and then 4. So 1, 2x. 1, 2, 3, 4. Okay, so this one represented 2 times 4x plus 2. The one we just did was 4, and that is 2x plus 1. Now, all of those are factored, but only one is factored correctly. And the one that's factored correctly is the one they take the most out of. And the most out of is, well, 4x plus 2, if you look at this one, well, I could still take more out of here, couldn't I? I could divide this by 2. But this one here, to see how there's nothing more I can actually divide out of here. So this one being closer to the square is actually your best answer. And the one that's farthest from the square will probably be your question. Okay, there hasn't even been any work done. So the trick is how we can go right from here, 8x plus 4, down to here, 4 times 2x plus 1. Okay, so remember you were giving me this. Now I want you to give me this, the dimensions that would give the best. Now, if you had, number 1, we have 4x tiles plus 12. Now what we're going to do is you're going to put brackets. And what is the greatest number I can divide out of both 4 and 12? 4. So if you take a 4 out, what would be left inside? 1x plus 3. So what do you do to get the 1x plus 3? Some people are so good at it, they don't even know how to explain it. Okay? It's like, there's some really, 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 really good hockey players out there that can't coach because they don't even know how they do it. Right? Technically, they don't know all the little things they do well. Right? And that's why some of the best players in the world don't go into coaching because they don't know. Right? They're just so good at it. It's just, right? Mechanical. Right? And the really, really good coaches out there are just so technical. They just know every little inch, the way you're standing and your feet aren't this far apart. You got to keep your head up, and you know, you're taking an extra stride here where you shouldn't be and you need to be over here. I mean, if you ever listen to really, really good coaches, it's like, wow, how do they know all that stuff? And they weren't even great hockey players, right? Because they didn't have the athletic ability, right? But they had the mental part of the game. So some people can't even explain how they get the 1x plus 3. So now no one wants to explain it because then they, yep. You divide 4 out. And the way I always check it is I multiply it back in quick. Because multiplication's fast, eh? Okay, 4x plus 12. Yeah, works. So I check every single one of them by doing the opposite after. Okay? So here's how we do them. You have your 6x plus 9. We want to factor something out. Take the greatest common factor. So 6x and 9 would be 3. So I take my 3. What will be left inside? 2x plus 3. And then you can double check quick. 6x plus 9. Yeah, it works. Okay. Now we're starting to get into separate entity here when we have numbers and variables. So, first of all, what is the biggest number I can take out? 2. So you want to put it a little farther away from the bracket when there's more than other things put out. But we're going to do the numbers first. What numbers would be left inside? 3 and positive 2, right? We want to put the positive 2 there because that's actually going to be my sign that's going to separate. Now, when it comes to variables, you're dividing out the x's too. But remember, when you divide powers, you subtract exponents. So what is the most number of x's I can take out? 1. Why can't I take out 2? Because 6x doesn't have 2 to give up. It's got to be common. What is common between them? Take it out. That's why it's called the greatest common factor. What is the biggest thing you guys have in common? Okay, let's show that. Let's bring it out. Okay, all your differences will be left inside the brackets. So, what would be left inside the brackets? 3 plus 2x. Good. So it's entirely backwards to what you've been thinking before. Because if I divide out the x, right, that's subtracting x to the 1. Or that's subtracting a 1. So if that was an x to the 1 and you subtract 1, that becomes x to the 0. Division is subtraction, yeah. So this is really, you know, the one thing that I like about math a lot is it is one thing that your brain actually hurts sometimes when you walk out of a math class, right? Because a lot of stuff's been going on upstairs, trying to fire at one time, figuring all this stuff out. And what's hard about these? You're doing everything in reverse, and you're dividing all of your numbers, and you're subtracting all of your exponents. A lot of stuff is going on. This is a very high level of learning. In fact, this unit would be the pinnacle, I believe, of math, right? Like, this is how, if people said, should I be taking 20-1 or 20-2? I'd say, hey, let's look at your factoring unit. Because we got so much factoring to do in grade 11 and grade 12. And I would say, if your factoring unit was like 85, 90%, yeah, you'd be good next year. Right? So you'd have the same mark as maybe someone, maybe you have an 80, maybe the other person got 100 and everything, but like got 25% on factoring. I would be worried about that person next year unless they brought their factoring up. So what is factoring? Okay, so to me, it's taking out as much as possible by using division. So what is the greatest common factor? That's really what it is. Taking out, well, what is the greatest thing that is common between them? right? So this makes the most sense out of anything. It is the greatest common and underlying common factors between all the terms. Okay, so here's the routine that I'd like you to get into. When you see 2x squared plus 10x, you put your brackets down, and you first want to find out, well, what is the biggest number I can divide out to? And don't put it right beside the bracket when you do that. Leave a little room, because you're going to be taking some other stuff out, and you're going to be like writing up the side of your bracket and over, and you know. So I take out my 2. So I want to divide each term by 2. This would leave me with 1 and positive 5. Does that make sense? Then, look at your variables. Do they have any common variables? So who's dictating how many we take out? The first term or the second term? The term with the least. The second term decides, because if you're going to take out the greatest common factor, the least guy gets to decide. All right? So x is common. So if I take an x out of both, that means I'm going to subtract the exponent 1. So it'll be 1x plus 5. And a really fast evaluation, right, would be 2x times 1x is 2x squared. 2x times 5 is 10x. I do that after every one of them, because actually I mess these up if I don't do that. Well, I can't catch my errors unless I do that. So just quick, oh yeah, okay, it works. Because these are easier ones. But obviously we're going to up the game here. Now 18xy squared and 27x cubed y squared. I'm going to show you the ugly way to do these, and then do them what I believe is an easier way to do these. But what I want to do is I want to do all the prime factors of 18. Okay? So 18, you can put a 2 in there, right? And you get a 9. And then you can put a 3, and then you get a 3. And then you can put a 3, and you get a 1. Okay? So 18 is 2 times 2 times 3. 2 times 2 is 4. Nope, 2 times 3 times 3. See? I checked it over, and I found my mistake. So 2 times 3 is 6. 3 times 6 is 18. Now, breaking up the variables would be times x times y times y. That is 18xy squared. Factored out. Prime factorization. You can't break that down anymore. That is the simplest you can get those two. Okay, 27. I put 3. 3 into 27 is 9. I put a 3. That gives me a 3. And then I put a 3, and that gives me a 1. So 27 is 3 times 3 times 3. And we got x cubed, so that's times x times x times x. And y squared is y times y. Now, why am I going through this way? Because this helps you understand that let's find everything common between these. Well, they both share these 3's. And they both share these 3's. That's common between them. They both share an x, and they both share 2 y's. So by looking at this, what is common between them? 9xy squared. Because 3 times x times y is 9x y squared. That's common. That is their GCF. 9xy squared. See, it's what is the most they have in common? Now, this is the way. So you'd go 18xy squared, and let's say it was plus 27x cubed y squared. So you go like this. What is the greatest number that they have in common together? 18 and 27. So you put out your 9. 18 divided by 9 is 2. And 27 divided by 9 is plus 3. Does that make sense? And you see, I always leave, I get the habit of leaving room all the time. It may look funny when you write down your answer, it's got all these spaces, but at least it's right, right? So you can rewrite it again, one line more if you want to make everything nice and condensed. Now, do the x's. What is the most x's they both have? 1. So you put an x to the 1 here. That would take the x out of the first term and leave me with x squared in the second one. Okay? Now, we've got y squared in both. So I will take out a y squared. You won't put anything because I've taken y squared out of both of them. So x9, this is what it would look like if you really wanted to make it kind of condensed looking. But we got the same GCF as above by splitting it up into its little things. Does this make sense? Yep. The 2, because 18 divided by 9 is 2, and 27 divided by 9 is 3. And if you want to check it quick, look, that is 18 plus 27. It's really quick to check them, and then you will realize how much easier multiplication is, right? Just bringing that in. Okay. So again, routine. Put those down. Work with just the numbers first. 6, 24, 12. Take out a 6. That, in the first term, that would leave me with a 1. Second term, positive 4. And last one, negative 2. Very good. Now you let's look at the A's. Who dictates how many A's I can take out? Yeah, so A is the best I'm going to do. Now subtract 1A from everybody. Now you're not subtracting 1A, are you? You're dividing. But that's how we have to think. Okay, yeah, I'm going to subtract exponential. So the first one, I will be left with an A to the 1. Now why am I putting 1 there when you don't have to? Because it's helping reinforce I just went 2 minus 1. Okay? In the second term, nothing. And the third term, nothing. Now, how about the B's?
So you only have an A out there?
1A is the best I could do. Because look, 1, 1, 2. The least dictates. Okay? So how many B's can I take out? 1B. In the first term would leave me with B squared. Second, just B in the third. Done. Okay? So this is the GCF, right? But that's the entire answer. Those two answers are identical. Well, one's kind of like, remember, I mean, this one we were getting a couple days ago. I give you this, and you had to come up with this. Right? You just multiplied it all in, distributed property, right? Now, I'm giving you this and saying, come up with the original question. What did it look like in the first place? Okay, so just all these lines have to do with all this. We don't really have to go through that anymore, because we did it. Okay, so let's do some. So these are definitely a skill that the more you practice it, the more it develops that part of your brain needing to do this stuff. But it's kind of like, you know, when you come up and it's all unraveled and you've got to kind of, you're tightening it up. You're, you know, just tidying up everything and making it all neat and getting everything that's all separated. Let's get it together, bring it outside. Okay, so in A, what is our number that we can divide out? 3. Okay, so I guess I should put my brackets first. I'm going to put a 3. So what would be in the first term for number? 3, and next one? -4. Very good. Okay, Tegan, I need you writing this stuff down. Why not in your book? Now, how about A's? So take out an A, would leave me with no A's inside. And B's, nothing. There's nothing common to take out, is there? You just leave it. And it should make sense, right? 3A times 3B is 9AB. And 3A times -4C is -12AC. Yeah. So, let's do B. Take out a 5. Yes, that's going to leave me with a 3. Next one. -2 and... Okay, so it's division first. Then it's dividing. We're dividing powers, but we subtract exponents, right? Always got to keep that in your head, right? What's the best I can do for x's? 1. Okay, what does that leave me in the first term? X in the second term? Nothing. Third term? Nothing. Okay. And anything else common I can take out? No. So, I'm not done yet though, right? Because I haven't taken care of the y's or z's. I haven't taken them out, so they must stay. Again, very, very quick to check. You should be able to do it in your head quite well. This would be 15x squared. This would be -10xy, and this would be -20xz. So always try and do the check after. Okay, C. C's nice and ugly. Let's tidy it up. Take out a 7, leaving me with 2, +3, and -5. Good. Okay, A's. A squared. So how many A's in the first one?
1.
Second, A to the 1, and third, none. Okay, anything else I can take out? B squared. In the first one, nothing. Second one, third one, B to the 1. Okay, so it messes with your head a bit, right? Because you've been so used to multiplying. Now you got to take it out. Yep.
How is A squared?
Because, let's go up, because this one has 2. This one has 2 plus 1. And this one has 2. Well, because this is A to the 3 divided by A to the 2, which equals A to the 1, right? Because you subtract exponents. Okay, D. Take out a 2. So I'd have 1 plus 1. Okay, what else? Okay, take out a pi. Both have pi's, so I'd be 1, 1 again. How many r's? I can take out 1 r. So that would leave me with R here and an H, right? Okay, next one. Next one's not for the weak. Some of you may cry. I'm doing this. But it's okay. We'll just pretend it's dust in here. Okay, so slow us down for what number did you take out?
4/3.
How did you know to take out a 4/3?
Because I put a 1 under the -4, and you had to find a common denominator.
Which is?
3, so 12/3.
Okay, so he changed this to 12/3. That is the insight you need to do this. Now, if you have 4/3 and 12/3, you can take out a 4/3. Why do you need to have a common denominator? Because if you had 4/3 and 12/3, you can just look at these to take out something common. And he took out the 4. So what would be left? So there'd be a 1 here and a... Okay, so if you... What happens when you take... oh, yeah, so it would be... If you take 4 12/3, you guys, and you divide by... Oops, don't ask why I put a 13, but that's what we're doing, right? 12/3 divided by 4/3, which is the same thing as 12/3 times 3/4. Those cancel. So you're left with 12/4, which equals 3. So that would be a 3 there, right? You're dividing. Okay? You would have to put -3. That's why I said this was going to be hard on you guys. Now what else? I can take out a pi out of everybody. Take out a pi. Okay, if I take out an r squared, 1r minus 3. Okay. So this one's a tough one because of the 4/3. Okay. It looks like a lot, but you guys have like 10 more minutes than the other class, and most of the other class finished. Okay? So I would be expecting very little homework, but then I have to admit I did do this for them. No, I actually used flowers. So I don't want you guys saying that you didn't get flowers too, and that's why we didn't do well in homework. And you know how it all starts.